Thank you everyone for coming today. And this is our School of Mining and Geosciences presentation. I'm going to turn things over to our presenters. Dr. Hazlitt, I think he might want to kick things off, but we'll kind of hold on to questions. If you have any, feel free to write them in the chat, but we'll leave time for questions and answers at the end of things as well. So with that, I'll hand things over to you, Dr. Hazlitt.
Thank you very much. Welcome. Let me start my screen sharing. Are you able to see that fine?
Yes, we can see it.
All right, great. Well, I just wanted to say some welcoming words, but really, those of you who are here and those of you who are watching the recording of this set of presentations are really the question you have is, what's of interest to you in the School of Mining and Geosciences? And some of you may already have decided you want to come our way. Some of you may just want to know what it's all about. So I am the dean. I've been at NUFYP University almost 3 years now, and it's a great school. I hope you'll agree with me because we have some fabulous career preparatory programs available to you. There's a lot of too many words on our mission statement, but I wanted you to see that, the school aim is to educate tomorrow's earth science leaders for Kazakhstan, the region, and the world. And it's in the School of Mining and Geosciences, we really prepare students for careers that are in demand in this country and around the world. So everything has international potential here. I'm not going to read all those words, you can later, but let me just say the connection to jobs is astounding. If you look in say, petroleum industry, we see $37 billion invested in 2016 to expand Tengiz. That's not to develop Tengiz, that's to expand Tengiz in the Caspian. And then you have Kashagan field is hitting record daily production, 400, I guess it's more than 400,000 barrels a day. That was a couple of years ago at $100 a barrel. Look at that income coming into the country of Kazakhstan. And then you turn to a mining program and you see that Kazakhstan has second largest uranium, chromium, lead, and zinc reserves in the world. And just the known mineral resources here in Kazakhstan has a net worth of $1 trillion. Okay, so that's the size of Microsoft or an Apple. Okay, so it's huge. This is a country rich in natural resources and development degrees in this area are in high demand for these industries. Geoscience connects everything in oil and gas and in mining. And so we really do connect with careers that are in demand with high pay and international potential. Here's a map. It's not been made current for a while, but it just shows you all over the map of Kazakhstan what are our known mineral resources. So they're everywhere. I mean, we know there's oil and gas in Caspian. We know there's mining out here in the east, but look, the whole map is covered and there's a lot that we haven't explored yet. Rare earth minerals in high demand in the future for things like non-renewable resources. Every wind turbine is going to need natural resource, natural high energy magnets. And the same is true of electric cars. If you think those are the panacea of tomorrow, they all need rare earth minerals. And Kazakhstan has them, and they're basically unexplored to a great degree. Inside our school, we have state-of-the-art facilities. I just show you a few pictures of some of our lab equipment, and students get hands-on experience, not only in the undergraduate courses, but also in your senior level research classes. And so with that, I just conclude these introductory remarks and say we do have career preparatory opportunities for you, and we would like for you to strongly consider joining us at the School of Mining and Geosciences. Thank you. I'm ready to turn over to one of my colleagues now. I'm not sure who's going to go next. Danya, who do you have scheduled to go next?
Okay, so hello everybody. My name is Zauresh Atakhanova. Today I would like to share with you about one of the 3 undergraduate programs at the School of Mining and Geosciences, which is the Bachelor of Science in Mining Engineering. So first of all, let me introduce myself. So I'm Zauresh Atakhanova. I'm associate professor at our school, and I have a background in mineral economics. I have a PhD degree from Colorado School of Mines in the USA. So Colorado School of Mines was a key partner for the School of Mining and Geosciences 5 years ago when our school was established. So basically, I'm here to help Nazarbayev University to develop programs similar in quality and kind of effectiveness outcome to this very renowned school in the field of mining, petroleum engineering, and geosciences. Anyway, so what is mining engineering? So mining engineering is one of the engineering disciplines. So it applies science and technology to extracting minerals from the earth. So the key thing that our Dean Hazlitt has mentioned what is that right now there is a very, very strong demand for all types of minerals, and there are several explanations for this. One is greater and greater digitization of many production processes. Even right now, at this particular moment, all of you are sitting in front of the computers or in front of you or using your smartphones, and each of these devices relies on key minerals that have to be mined, that have to be extracted from the earth. So on this diagram, you can see that even a cell phone needs a whole set of minerals that need to be, of course, discovered, extracted, produced, and then used in the manufacturing process. So as you know, many of, yeah.
I'm sorry for interrupting, but I see still your cover slide here, and I think we're talking about some other diagram.
Yeah.
I'm not sure about others, but I'm still on your introductory page. First slide.
Okay, let me try it one more time. Okay, so I'll keep it as this type of presentation. So what I was talking about is this slide. Can you see it now? The slide with a cell phone?
No.
Yes.
Oh, yes.
Slide number 4. Yes.
Yes. So thank you. Thank you, Milovan and Professor Fustic for letting me know about this. So basically, the point is that the ongoing process of involving digital technologies in our everyday life, but definitely, of course, in many, many different types of production activities, it requires indirectly, represents a very, very strong and increasing demand for minerals. So digitization is one reason why more and more resources need to be extracted from the earth, minerals, but there are also other processes that are very important for supporting this very strong demand for minerals. So as you have just heard, the next explanation for why we need mining engineers to support this process is the way in which we are using energy is changing constantly. And of course, you know now that there's a very strong demand, change in the way that we are fueling our vehicles, right? So the expectation is that soon electric vehicles are going to displace the traditional vehicles. And one of the key components that makes electric vehicles attractive, but at the same time represents a to some degree a challenge, is the battery. So we need very powerful batteries to power our cars, our trucks, and these batteries, they require key resources. The battery of a car, of electric vehicle, is the most expensive, most valuable component. And such electric vehicles rely on the use of this very, very important mineral, lithium, in lithium-ion batteries. So there is a very strong and very quickly increasing demand for this mineral, lithium, that needs to be extracted. And one of the potential locations for future production is Central Asia, including Kazakhstan. So in the future, there's going to be a very high level of activity for exploration and also for production of a wide range of minerals. Another issue that that is very closely related to this one is the greater and greater use of renewable energy sources that are expected to replace the use of fossil fuels, or at least reduce the importance of the fossil fuels. So what do we mean by renewable energy? It's those types of energy sources that as we use them, the stock of such energy sources remains the same, unreduced. So wind power, hydropower, geothermal energy, solar energy, they are all examples of renewable energy sources. Why are they becoming so critical for the society at the moment is the challenge of climate change. So basically, the goal that the humanity has put in front of it, many governments supported, is trying to keep the increase in the temperature under the 2 degrees by the end of the century. But in order to do this and to support the spread of renewable energy sources, you need to extract many different types of minerals, because all renewable energy sources are very capital intensive. They use a lot and very large structures. And as a result, there is demand for many different types of minerals to support this energy transition. So here you can see on this graph the expected increase in demand for various energy sources. Basically, mining and mining engineers are the ones that are going to play a key role in helping the society making the transition to a greater and greater use of renewable energy sources as that rely on many minerals that have to be extracted from Earth. So as a result, there is a very, very strong demand for minerals and mining engineers that need to be involved in this process. So demand for mining engineers is very strong, not only in Kazakhstan, but everywhere in the world. There is a shortage of mining engineers. So basically that means that if you manage to finish the program of mining engineering in Kazakhstan, you are basically guaranteed to have a well-paid and also very interested job in our country. And then depending on your qualifications and your experience and kind of resourcefulness, it is quite possible that later on you'll be able to find interesting jobs even outside of our country. So in the kind of common mind, the stereotype is that mining is even nowadays is very kind of reliant on manual labor, involves working in unsafe conditions, but these are all mostly pictures from the past. Nowadays, mining is highly computerized. A lot of the automated technologies are used. It's very different. The types of skills that are used now in mining are considerably different from what they used to be in the past. So here, not only do you need to understand, be kind of well-versed in pure mining engineering subjects and skills, more and more computer skills, high-level computer skills, as well as other types of skills such as leadership skills, communication skills. They are all important for mining engineering. It's not anymore like it used to be in the past. It's a very modern and quickly changing type of a job. So if you choose to become a mining engineer, what kind of tasks are you likely to be involved in? So mining engineers, they prepare designs, plans, and schedule for mining operations. Because mining itself relies on a lot of natural resources, it needs to constantly be mining engineers, they need to be constantly involved in research and development in order to reduce the use of resources for its production, as well as reduce any type of environmental impacts. So mining engineers are involved as a result, and not only in research and development, but also a lot of mining engineers work as consultants for mining companies, for governments, for international organizations, and some mining engineers work as analysts. So there are very many different types of career paths that are open to those who choose mining engineering. So in Kazakhstan, there are many well-known, very successful international mining companies present, such as Rio Tinto, SRK, but also local companies such as Kazminerals, Kazzinc, Kazatomprom. They have, of course, you recognize their names. These are very large and very successful companies that, to a large degree, support not only the local communities, but generate very, very significant tax receipts for our government, and indirectly support many public services in our country, such as education and healthcare. So there are several specializations open to mining engineers. You may specialize in open pit mining or in underground mining. As a mining engineer, again, you may be working as a consultant or as a researcher. Okay. So if you join our program during the first 2 years, your studies will be very similar to other engineering students at the university. So you will be learning core subjects in calculus, physics, chemistry, and computer sciences. But as you progress in the program, you're going to start taking more specialized courses. Of course, one of such key courses will be geology. You'll be spending quite a bit of time in the class, in the labs, and also probably taking some field trips. Okay. Other courses that you are likely to take are resource modeling, where you are going to be learning about specialized software and improving significantly your computer skills, computer programming skills. Another course that's very important is geomechanics, where you learn about mechanical properties of rocks. This is a core course in our program. And one of the high-level courses is mine planning and design. Again, here you rely on use of specialized software. You will practice, you will learn how you can use such software to design surface mines and underground mines. Okay, so I think this is a very exciting program. As our dean has informed you, there is state-of-the-art equipment that is available in our labs. Students have work experience, they work in real mines, so that this is very exciting, I think. So who will be teaching you if you decide to join our program? So here I have some brief description of some of our faculty. So basically faculty comes from all over the world, from leading programs in mining engineering in such countries as Canada. Here you see Professor Ali Mortazavi. On the bottom, you see some of the examples of projects in which students were involved while working with Professor Mortazavi. So he's an expert in mine planning and rock fragmentation. Another senior professor in our school is Professor Surineni. His specialization is in mining systems, rock mass characterization. Again, students were involved in working together with Professor Surineni. Professor Eleonora Capehart has a lot of experience in working in many countries, in the United States, in Australia, in Chile. She is a specialist in automation. Next, another professor that you may be studying with is Professor Sergei Sabanov. He has a lot of experience in business consulting, and his key area of specialization is mine ventilation. Okay, just a couple more professors left here that I would like to mention. Professor Safet Yagiz has an expertise in mining excavation. Many students work with this professor. Professor Nasser Madani specializes in geostatistics and resource estimation. And finally, but not least important, is Professor Kofi. His expertise in rock mechanics. Okay. So basically, if you're interested in our program, please feel free to contact us and explore our social media. Of course, at the end of our today's presentation, I'll be happy to answer any questions on the mining engineering program at our School of Mining and Geosciences. Thank you.
All right, well, thank you very much. And I guess the next presenter, is that you, Professor Fustic?
I can certainly do it. I think I was supposed to be the last one, but I can certainly do it.
Oh, I apologize. Who should be before you?
Dr. Wong?
Oh, okay. Let me, sorry, I don't think I have you as a presenter. There we go. I've made you a co-host now. So Dr. Wong, you can share your screen. Oh, great.
Ray, in case you are talking, we are not hearing you. Ray, we don't hear you.
I can test your microphone. We're not getting anything. Ah, now it's working. It was. It stopped. Perhaps we should go with Milovan if Lay doesn't get back, and Lay may need to disconnect and reconnect.
I'm happy to do that. So, good afternoon, everyone. Can you see my screen?
Yes, we can see it.
Okay, excellent. So, first I apologize that my home computer doesn't have the best audio, but I hope it will be manageable. That you can understand. So, my name is Milo Acoustic, and I'm professor in geosciences. I have several slides to introduce you to geoscience program, but first I'd like to say a few words about colleagues in the department. So we collaborate very, very closely with our colleagues in mining and petroleum programs. So I'm teaching, for example, some courses in their program, some of them teaching in our program, so we are very, very much interconnected. So Zaudesh have already introduced some of the colleagues, most of the colleagues in the mining department. And in addition to that, Zaudesh said very, very good things there, for example, about the energy transition and so on. I would say everything what she was talking there about finding lithium, other alternative resources, all of that is really related to geology. But you cannot start mining lithium before knowing where this lithium is. So there is a strong interconnection between our disciplines. So in this lecture now, I will tell you a few things. So essentially, I will say a bit about geosciences in general, and we will say we divide geoscience in two parts. So fundamental geosciences, where we learn about how Earth is working and so on, and then applied, which provides some solutions, which is actually natural link to natural resources and operations and so on. And I will tell you a few things about geoscience courses in our program. Unlike other my colleagues who are usually talking about big things, big opportunities, I will mention some big challenges. So challenges of the present day society, present day world that we are trying to resolve. And actually, I really believe that as a geoscientist and mining and petroleum engineers, that we are solution for the future of the planet. So I hope I will illustrate it pretty good to you. And then about some education opportunities during your program. So first few things about these fundamental sciences. Fundamental geoscience is what it is. It's basically geology, is studying life and evolution. So what we're looking at this diagram here, we see a scale. It's a very simple scale. So on a vertical scale here, y-axis will be the number of the species that exist in the world, and on the horizontal axis is the time. So time on the left side here, 542 million years ago, basically the life occurred on the Earth until the present day. So you can see that diversity actually increased over time quite a lot. So here there is increase, and now we have quite a lot of diversity. Right? But this wasn't going smooth up. You see several of these periods here, and many species were disappearing on the Earth. And these are some principles with big extinctions. So most of you are familiar with these extinctions of dinosaurs, which occur here along this Cretaceous Paleogene boundary, for example. There are some others which are also very, very important, which are occurring. studying them is important. One thing, yeah, it's cool to know these things, it's cool to know about the past, but also past provides us some clues about things, what can happen in the future. For example, now changing climate, because all of these big extinctions that occur, you know why they occur? They occur because of climate change. And I will talk about that a bit later. So learning from the past what was happening, we actually should be aware and try to mitigate a similar impact in the future. So here is my colleague Laurent with a group of students in Caribbean depression. So they are looking some of these layers there with the extinction, for example, and looking at some specific fossils which occurred before the boundary, and some of them which occurred later. So geology is also study of the earth. So we are studying everything from the inner core to the lithosphere, and even going to cosmic geology. So we're talking about big thing here. We're talking about how continents are moving, right? What is happening under the earth, and all of that. Okay, one thing is cool from fundamental science point of view, but another thing, also all of that controls where our mineral resources will occur, and mineral resources that we are interested in. So last 50 years, we learned a lot about where we will find oil, a lot where we will find coal. Right now, we are at the beginning. We are now learning where we will find lithium, where we will find cobalt, and so on. So we are kind of a new frontiers now, but these answers are answered by us in geology together with colleagues in mining engineering. So this image here, for example, on the right side shows how plates are moving nowadays. So we see that this Arabian plate is opening, moving towards the north, right, and forming space where now water is invading it, forming the Red Sea, and on the other side we have a collision of the plates where mountains are formed. And that's what we see on a big scale, but here on the left side our colleague Mahal Sirat, who is teaching structural geology, he's showing some of this deformation, like when we have effects of these collisions. He's showing that now in the Asan Basin. And when these collisions occur, when we have this breakup of rocks, when we have circulation of the fluids, and we have mineralization there. So all of that is interconnected, and it's really cool to study that and then to see how these mineralizations are occurring, where we will look for resources, and how we will make our future more different and better by finding opportunities. So this diagram on the right side is very close to my heart. This is something that I'm teaching about petroleum geology. For example, so there are kind of three components here. The first one, how organic matter is formed in the oceans or in the lakes, right? And how it's preserved, and then finally how it's transformed into oil, and where we search for oil and so on. So there is actually, it's not just to go and say drill here. There is lots of cool science behind it that we need to learn, that we need to understand in order to find oil. There is an expression which I'm starting my petroleum geology class, and this expression is finding oil is same as finding a needle in a haystack, right? And this is really how it is. But it's cool when you apply different technologies. That actually a big haystack you can find a needle. So similar processes are occurring, are controlling occurrences of other mineral resources in the subsurface. So we also analyze that, learn about these processes, and learn where mineralizations can occur. So now going a bit closer, going about Kazakhstan. So Dean Hazlet already showed to you a way better diagram than I have here about all kind of different resources from uranium and so on. This one is showing here just kind of major west fields in the west. Now we have oil fields in Chusarichu Basin, here in the Asan Basin as well, and so on. This is not limited, but what we need for these resources, we know that there is way more of them. We need people like you to learn about the elemental fundamental sciences there, and then try to apply it and find more. Then very important thing, to manage production from available resources. But in geology, we're not just finding them. So for example, we have Uzan field, which is discovered in 1960. It's still producing. It's been producing for a few more decades, at least. Right? With new technologies, but these technologies are based on understanding geology of the reservoir. So, okay, so Dr. Hazlet mentioned these big companies which are involved here, including Chevron, Total, Shell, and so on. So now a few things about what you will learn. So what kind of courses? So in the first year, you have actually kind of basic things to learn, calculus, chemistry. You have introduction to geology, kind of fundamentals of geology. You have course in natural resource extraction. So you get some sort of fundamentals. Then in the second year, you start learning more. You start learning about mapping. So this mapping is really cool because what allows you, by observing some things which are on the surface, allows you to predict what is below your feet, what you can find 10 meters before you, 100 meters below your feet, 1 kilometer, 5 kilometers below. And that's really cool. I can tell you, this is more cool than rocket science to predict what is below the surface. And then these things which are below the surface, actually, where you can find economical resources which are there. Then mineralogy. So we have very nice rock collection here, minerals, rocks, and so on. That you will introduce to a variety of different crystal forms and rock forms. In the second semester, you are learning about sedimentology, petrology, paleontology, history of life, and so on. And then you have your first field geology course. Actually, you are introduced to field geology before that. I just came back this morning, actually, with a group of students from Manistau. As a part of our sedimentology and stratigraphy course, we spent 3 days there. So we looked cliffs in Actau, we looked some modern depositional setting just south of Actau, with lagoon, beach deposits, Aeolian deep deposits. Then we went to KNG and we logged some cores, which are actually from Musan Field, 1,200 meters below the surface. And students did amazing work there. And then on the third day, we went to the Caratao Mountains there, so we looked these big concretions, we look all stratigraphy, how actually world evolved in this part of the planet from Triassic time until present. So many different kind of forms. So I will go quickly through this one here. So your courses are getting more and more technical. So hydrogeology, structural geology, sustainable development, geophysics. And then at the end of the third year, you are going to your field geology 2. Then you are going to Eastern Kazakhstan there for about 2 weeks. And I forgot to mention here is field geology 1. This is at the end of the second year. Then we are going for about 2 weeks to southern Kazakhstan, mostly around Taraz there, and we look at all kinds of different deposits there. We are visiting a couple of mines and discussing mineralization there. We are looking at analogs for Tennis fields and so on. And then you come to the fourth year, you have very advanced courses here in training geology, geochemistry, geology for deposits, and then you start working on your Capstone project. So you pick your supervisor, you pick the topic, you start doing the literature review, and then in the last semester we are actually working on research, which is defining this research. We are utilizing some of our labs. We are just world-class labs at the university. We have some elective courses which allows you to focus on, to help you with focusing on technical aspects of your research project. So just few comments here about the way of learning. So when you're in academic world, it's not about memorization. It's not what I tell you. There are this subdivision of 5 types of minerals, for example, cobalt and so on, and that you repeat. No, this is not the way. This is not the way in advanced academic world. So essentially, as Einstein said, education is not the learning of facts, but the training of the mind to think. So myself and all my colleagues in SMG will help you to develop really strong critical thinking skills, really strong observation skills, in order to create a new value by yourself. So this is actually the diagram of learning. So yes, you need to remember some basic facts here. The ultimate goal here is to go up in this Bloom taxonomy. So one thing is to remember. Second thing is to understand. Once when you understand solution in one area, you can apply that into another area. And then we know how to analyze things, then you can evaluate and actually create a new value. And this new value is really important. Why it's important? Because we are facing two very big problems here in Kazakhstan. One in Kazakhstan, another in the world. The big problem with Kazakhstan is stated here. So, with Kazakhstan, согласно исследованию компании IHS Markit, средняя цена барреля нафты, при которой добыча в Казахстане будет стабильной, равна в среднем $46 за баррель на суше и $51 на море. So, okay, today when oil price is $100, yes, we have big profit. 2 years ago, oil price was $20. And we still know that this is the most expensive production, one of the most expensive in the world, right? With a little bit of science, with a little bit of solutions, with a little bit of critical thinking and how to make things different, I guarantee that each and every one of you can impact that and reduce this cost down to $40, down to $30, down to $20, and at the same time reduce the impact on the environment by using less energy to produce it. The second big thing is a global thing. This is climate change. So, Zauresh already was talking to you about climate change. I mentioned a little bit about these extinctions. I can just say one word, in one sentence. Every extinction that we had in the past, what species disappeared the first? The most advanced species. So nowadays, the most advanced species are us. So in these climate changes, they're talking about untold suffering. Vital signs, indicators of magnitude of the climate emergency. So this is really serious problem that we, as a global community, we need to address. So both of these problems approach is the same. So how science works? We identify the problem. Now we know what the problem is. It's high production cost. It's high CO2 emission. So we know that we're looking for solutions. And then we come with solutions, we come with some technology, and new ideas are coming. Basically, science is very simple. It goes into these three items: observation, solution, new observation, new solutions, and so on. And having said that, one of solutions, for example, climate change, is carbon storage. Who is doing carbon storage? Is us in geology and mining and petroleum engineering. We know the subsurface. We know where to put that. We know how to store that. Other solutions is geothermal, right? So who knows the reservoir dam? It's us in SMG. So we have subsurface expertise for that. And for all other green solutions, actually geology and petroleum engineering and mining solution. So we'll skip that. This is a little bit about uranium. I know that I'm a bit over time. And but yeah, uranium is essentially really huge, good potential here in Kazakhstan. It's already the biggest producer of uranium in the world. There are more opportunities to improve that. We have a big project with Khatko, which operates there. They're talking about Kazatomprom, and none of upcoming slides I will show you actually work that one of our undergrad students is working with them. So we have a very nice labs here, really good microscope that you will use even in your second year. So here is the drone that we are using in the field management to collect samples and studies. We have nice rock collection. So we do lots of field work, as I said to you. So here is an image from 2 years ago when we went to Aktau. I posted it on LinkedIn, and then within 2 weeks we had almost 40,000 views. I mean, it's definitely attracted lots of attention there. So we look out for, for, and I mean, students have opportunity to learn really a lot there in the field, and really to apply their skills later. So when I say to apply their skills later, so he residing, so he's working on a pool in Orano. So what he's doing here, he's actually doing some measurements to identify one of the major events that happened in the history of Earth, petroleum maximum, but also how that climate changes that occur at this time are impacting mineralization of uranium. So pretty cool thing, pretty important thing. The last thing, so it's you will be very much encouraged here to publish your results from the Capstone project, conferences, to present that. So you can see here it's Heidi, Alan, they are all undergrad students. So they were part of bigger projects that we presented internationally. to international communities, and it's very important to publish it now. So we have really world-class instruments in our shared facilities as well. Dr. Hazard showed to you some world-class instruments. We have an SMG. We have an opportunity to play development. So at the end, where we will work, obviously we can work as a geologist in mining industry, petroleum industry, in environmental protections, in these new technologies like carbon storage, geothermal energy, water resources, of course, academia, all government authorities have their geological committees or geological surveys, and so on. So with that, I will conclude my presentation about geoscience program. I'm happy to talk to you more about that. So, but in essence, if I need to summarize what I said to you, so we are dealing here with some great opportunities, but also some great challenges that exist, and I like you to consider to be part of the problem in resolving these issues. The image that you see here is from Kenderlick Trough. This is close to China border, and one of our PhD students did actually very cool study here. It's a preparation of publication about origin of black shale there. Huge potential for new resources, new petroleum resources in Eastern Kazakhstan, and I really believe she did just very impactful research and findings. Thank you very much.
All right, thank you very much, Dr. Fustic. I think Dr. Wong is now going to present, and I think he's gotten his microphone issue sorted, so I'll go ahead and hand things over.
Okay, Eric, can you hear me?
It's a little echoey, but yes, I can hear you.
So is this better?
Yes, much better.
Okay. Hello, everyone. So my name is Wong. Okay, so I'm an assistant professor in Department of Petroleum Engineering at SMG at NU. Okay, so today I'm going to present the undergraduate program of petroleum engineering to all of us here. Okay. So what is petroleum? So anyone knows? Okay. So petroleum is essentially crude oil and natural gas. Okay. So I think everyone already saw some crude oil samples before, right? Pretty much like this one. As you can see here, I have a graduate cylinder filled with this black liquid, right? They look like a cup of coffee, isn't it? Okay, so we also have some crude oil that has very high viscosity. For example, here, a technician is pouring some oil out of a beaker. As you can see, it looks like molasses, right? It's very viscous. Okay, so these are all crude oil. And also, we have something like this. Okay, as you can see, it's like a bottle of water, isn't it? Okay, the liquid inside the bottle is transparent. This is another kind of crude oil that is being produced in one of these oil fields in the world. Okay, so more pictures. This one looks like maybe a green lemonade, correct? Like something that is drinkable, okay? But don't be fooled. As you can see, the background, okay? This production platform pipelines, okay? This is another kind of crude oil. So it has this color, kind of a greenish. Okay, so we also have some crude oil that has this bluish appearance. Okay, something yellow. And yeah, this one, as you can say, looks like a green apple juice, right? Okay, some crude oil even have red colors. Okay, this one, some color in between yellow and red. And also we have some waxy oils. They look like butter. Okay, so all these are crude oils. Okay, as you can see, the petroleum industry, or let's say the crude oil by itself, is a colorful world. Okay, so the industry basically is a colorful world that waits for all of us, all of you, to explore if you want to become a petroleum engineer. Okay, so we have all this oil produced from underground. Of course, we have natural gas produced from gas reservoirs. Okay, so how are we using them in our daily life and in our human society? I believe you all know these things, right? Rockets, airplanes, and every day you see these cars, trucks running on the road, right? So they are burning fuels, okay? So most of this fuel are essentially petroleum products. In addition to these fuels, or lubricants and bitumens, okay, we have other products that are made from chemicals derived from crude oil and natural gas. For example, right now, we are looking at our laptops, our mobile phones. Okay, many of these electronic parts, they are made from chemicals derived from oil. Okay, girls are using cosmetics, right? Detergents used for washing clothes, house paint, plastic bottles, rainbows, okay, tires, okay, plastic bags, hot air balloons, okay, optical media, all these things are made of chemicals derived from oil refinery. Okay, so now you say how important crude oil or petroleum is to us, like to our daily life and also this modern society. As you can see, without crude oil, without petroleum, our life will become very, very inconvenient. Okay, now let me introduce the faculty members in our petroleum engineering department. At the beginning, you already met Professor Hazlitt. His expertise includes well testing analysis, development of unconventional reservoirs, and also computational fluid dynamics. We also have Prof. Sherry with the specialization in production engineering, and also Professor Sony specializing in drilling engineering, like how to drill a well from surface down to the reservoir with like thousands of feet underground. Okay, we also have Professor Sarfay. His research covers well logging and formation evaluation. We also have Dr. Abbas. Her interests includes reservoir engineering, chemical EOR, reservoir characterization. And finally me, okay, I'm working on reservoir simulation and applying machine learning and AI techniques to reservoir engineering, okay? And all of our faculty members here have abundant teaching and research experience at international universities before joining NU, joining the petroleum engineering department. And as you can see here, these full-fledged research interests. Okay, this research interest in these bullet points covers all directions in petroleum engineering. That's if you want to major in a specific direction, you can always find a supervisor in the department. In addition, we are closely collaborating with our strategic partner, Colorado School of Mines in the United States of America. Okay, so we are developing these undergraduate programs, the programs you are going to get admitted, the master program, and also the PhD programs through design of program courses. Okay, we are sharing the teaching, the learning materials from Colorado School of Mines. Okay, and we are developing joint research lab infrastructure for graduate students and graduate students. And also our strategic partner provides trainings for the lab staff and also the faculty members in our department. Okay, so as an undergraduate student, at some point, for example, the last year, you could have the chance to visit Colorado School of Mines to spend, let's say, 1 to 3 months over there to study some courses, to do research with professors over there. Okay, you all have these opportunities together with the master students and also PhD students. And after graduation, let's say you want to apply to graduate school, of course, you would have the advantage over other graduate students from like other universities if you apply Colorado School of Mines. Okay, so besides, we are closely cooperating with the oil and gas companies operating in Kazakhstan. For example, Chevron, this Gas, Total, SMG, Halliburton. Okay, these companies provide a lot of internship positions to our undergraduate students and graduate students. Okay, in addition, let's say after the internship, you perform very well and the company is satisfied with you, and they could provide this long-term employment to us. Also, we are doing research projects with these companies, and you will have the opportunity to get involved in these very practical research projects. Like, for example, to solve a problem these companies encountered in the North Caspian Sea oil field. Okay, in our school, we have a lot of well-equipped laboratories for petroleum energy. Okay, for example, the first one, as you can see here, it is the drilling simulation lab. Okay, so what you are seeing here is a drilling simulator. Okay, if you operate it within this room, the platform can vibrate in real time. This is really helpful. Okay, it will kind of mimic all these conditions you could probably encounter on the real platform in oil fields. So it will get you prepared for all these internships in these oil and gas companies. And also we have this drilling fluid lab. You can prepare and evaluate the drilling fluid properties. The core analysis lab, by obtaining these cores from these reservoir formations, we can analyze the basic properties like porosity and permeability, okay, fracture networks, all these things. We also have the rock mechanics lab, fluid characterization lab, and some thin section lab. So all, as you can see here, are available in our school at NU. So I have been working at quite a few different petroleum engineering departments in the United States and also visit some labs in Europe, I can tell you that these laboratories represent world-class state-of-art equipment. Okay, that means NU is one of the best, has one of the best petroleum engineering programs in the world. Okay, so after entering the undergraduate program, so what are we going to learn? So for the first year, basically you will take some fundamental courses. Okay, starting from the second year, you will take some subject courses. And in the last year, in addition to these courses, you will also have the chance to do capstone design project, which is related to research. Okay, you will have the opportunity to closely work with one of these professors or two of these professors in department to finish a research project that you are particularly interested in. Okay, so for drilling engineering completion, it is related to how to drill a well, like onshore and of course offshore. Okay, how to produce this oil and gas from the reservoirs, both onshore and offshore. Okay. About this reservoir engineering and the reservoir simulation, we are going to build some simulation models to simulate, let's say, the fluid flow in reservoirs like thousands of meters deep. Okay, and on the managerial economics side, you are going to evaluate the basic economics about the oil and gas operations. Okay. So here, whoops, it already popped up. So I was planning to ask you a question like, what's the oil price today? Okay, so I checked it an hour ago. It's about $100. This price is relatively high. Okay, that means to some extent, the supply of the oil and gas to our human society is not sufficient. We need a lot of you to become petroleum engineers to help develop these oil and gas resources. Okay, so as you can say, this is our daily life of students working in the laboratory. Okay, this is a rheology lab. This is a rock mechanics lab. This is showing students operating the drilling simulator. Okay, and of course you will need to communicate with each other to work on the team to finish some collaborative project, final project on the course and also on the research side. Okay, so this is pretty much our daily life. Thank you, and I would be happy to answer any questions related to petroleum engineering.
Thank you very much, Dr. Wong. Does anyone have any questions? You can type them in the chat or you can just go ahead and ask them. That's fine. No need to be shy. Anyone? Well, I don't know that anyone has any questions. I found the presentations particularly interesting, and I appreciate you taking the time to deliver them. But I don't know that we've got any students that have any questions right now. So. Going once, going twice.
Well, I can just comment and then you can
Sure.
close out. And those of you who are here have friends who either left early or weren't able to join us, let them know that the recording will be available. But many of you are probably, wondering about the new system. Oh, someone's trying to come in now. The new system, and of course, if you meet all of the metrics, you'll be able to progress to the school of your choice. And we ask our students in SMG to declare majors. So we've seen the 3 programs that we have. That's all we have right now. We have graduate programs for those of you with long-term interests in master's and PhD with the engineering disciplines, the mining and petroleum. We're trying to position ourselves to offer graduate programs in the geosciences because they're very much needed here in this country to help run exploration programs. So we're working on that. But for those of you interested in applying, please pay particular attention to your scope of work. We want students that are passionate about what they want to study. Math and science, we drew you to engineering or geology, and you may not have known much about what are your choices in, say, engineering discipline, or that geology was even offered amongst the natural sciences. So our school is a bit different. We grab a couple of engineering disciplines and one natural science discipline and form our own school. But believe me, we all work together. We all deal with natural resources. We are planning on starting programs in natural resource management to go along with our extraction technologies. And of course, geoscience is common across the ground, as well as environmental type of situations and projects. Anyway, that's where we're heading. So please, express yourself fully and let us know, why you want to come to the School of Mining and Geosciences. We do look at, because you're a NUFYP and you've got tutors who've tracked your progress. We do, unlike maybe some of the other schools that just do a numerical ranking, we do take those comments into account in our final decision. So we encourage you to do your best to finish strong so that you will get where you want to be. All right. We want people who are passionate about these kind of careers, as we are. And if this is your cup of tea for a lifetime, please, come and join us. Thank you.
Right. There was a question that was put in the chat here. And it looks like it's sort of saying something about some of the statistics for admission. I usually, well, I don't know exactly what the numbers were for last year as far as students coming in from NUFYP. But he's saying it looks like is there big competition for mining faculty? I think that maybe they mean students rather than faculty, but I'm not sure.
We can try to answer a couple different ways. Maybe that'll cover the bases.
Okay.
Because you asked about SAT. Statistics for admission. I mean, we have 25 slots in each of the 3 programs, and historically we've filled those, and then we've lost some students. But so our graduating class, we're going to graduate our first graduating classes with undergraduate degrees this year. So the class size is more, well, because it was 4 years ago, the students are entering. Our program wasn't as well known also. So we didn't meet our goals of 25 students 4 years ago. And so our graduating classes in each of the programs is around 10, a little bit more in petroleum because the demand was higher in petroleum, a little bit more well-known program for Kazakhstan, even though SMG was brand new. So that's the story. We have 25 state grants available for incoming students. SAT results, SAT is only one way to get in, and I can't really comment on the numbers for SAT coming to SMG, but if you have the SAT, we do look at those. Those are when we used to have subject tests. We looked at the the math, and we took physics. We looked at those carefully, more so than some of the other courses. About faculty, well, it's quite different between the disciplines. I mean, there's a great demand for employees in all three, but if you're asking about faculty, one, you really need to have a PhD. So if you're entering undergraduate with plans on academics, you should set your sights on getting into a good research program as an undergrad, especially in your capstone project. We are a research-intensive university, and that spills down even to the undergraduate level. So we do prepare you. You do a good job on your project. You have basically a senior thesis. It will help you get into graduate school. And master's degree is basically a introduction on how to do research. And then the PhD is a whole change of mindset. And how do you think about solving unsolved problems? As in the master's program, your faculty will give you a project that is doable, okay, within the time frame. So that part has already been determined. Hey, here I have this cool project you can work on, and I know you're gonna, you're a good student. You're gonna finish. All right, you're gonna finish this task, as opposed to a PhD student who's around who part of their responsibility in graduating is to contribute something new, something brand new to the field of science. It's more challenging, and the student takes more ownership of their project. And basically, you cannot map out a research project for 4 years and everything goes smoothly. It's how do you adjust to things that were unforeseen, and sometimes that brings forward some of the best results. You find something you weren't expecting, and you run down that rabbit hole instead of what you did planned initially. Anyway, I don't know if that answered your question. Worldwide demand for faculty, and again, it varies between disciplines. Mining is heading much more into automation, but we need mines. I mean, these machines don't run themselves. So people have to program and monitor everything, and exploration programs they're human run programs. So you can't, maybe someday we'll send little rovers out to collect samples, but maybe it'll happen on Mars before we do it here, Kazakhstan. Petroleum, yeah, there's still a big demand for petroleum engineers, and all the technologies that people may want in the future for geothermal and similar types of technologies that are green conversion of hydrogen. In hydrogen fuel, well, the primary source they're going to be hydrocarbon, okay, and you've got to liberate the hydrogen and then sequester the carbon. So there's the technology is going to be needed for your whole lifetime, and we will not, despite what you hear, we will not be 100% renewable anytime within the next few generations, barring some fabulous discovery from physics regarding fusion. Then in geoscience, faculty for geoscience, we have ongoing searches for for geoscientists and for engineers in our own school, and we're finding it difficult to find good, strong candidates. So if you if you take control of your career and you steer it and you do well, there will be a job waiting for you, whether it's at the end of your bachelor's degree or at the end of your graduate studies. Don't worry, it'll be there. Just concentrate on what you're doing and do it to the best of your ability.
All right, well, thank you very much. I think that did answer the question. At least he's written thank you, so, or she. Are there any other questions? I know, Igarim, you've been trying to kind of get in and you've been booted out and you've gotten in again. I didn't know if you had any questions, but if not, I suppose we can go ahead and wrap things up. With that, I will stop the recording, but thank you everyone for your presentations and for your attention.